Good evening, everybody. Good afternoon, good morning, depending when you're watching. I'm Matthew Polinsky with the Manitoba Tech Transfer Program. So tonight we're bringing you a presentation with Dr. Zac Lamas. And just before we get started, I just wanted to mention that our Manitoba Beekeepers Association Field Day is coming up this Saturday here in Manitoba. So if you're local, come on out to the field day, check it out on the website. Another thing that's going to be happening in July is we'll be hosting a webinar about RNAi for Varroa control, looking at some of the field results based on a study out of the US, New Zealand, and across Canada. So look out for advertising about that. So I'll introduce Dr. Zac Lamas, and then we'll bring him up on stage, and he'll give us about a 20-minute presentation. And after that, we're going to have some discussion with some local beekeepers here who are in on our live stream today. We got Phil Veldhuis, Nazari Daikev, Ian Stepler. Brad Hogg might join us later, as well as Cham Elga. So we'll see them after Zac's presentation, have a bit of discussion. So put your questions in the chat, and even better, if you hold some of those really strong questions to the end, I'll be able to pick them out really easily. So put them in the chat though, and we'll address them later on. So I'm just going to bring in Zac here. I just want to introduce Zac by saying he is a visiting researcher at the University of Maryland, Baltimore County, where he runs the Honeybee Disease Ecology Lab. He focuses on Varroa feeding. He focuses on how Varroa feeding behavior drives viral transmission in a honeybee colony. His previous work uncovered that the ideal adult bee host for Varroa was misidentified nearly for 30 years. Varroa actually aggregate on adult drones and only shift onto worker bees when drones seasonally disappear from a colony. He is now using his previous finding, weaponizing that info against Varroa, and his hope is to create an effective bait trap for cost-effective Varroa control. Zac previously worked under Dr. Jay Evans at the Beltsville Bee Lab, leading the federal field response to the severe losses in 2023 and 2025. And he previously worked for Michael Palmer at French Hill Apiaries in St. Albans, Vermont. Zac is also the scientific advisor for Hive Armor Bioscience. So I'm just going to welcome Zac. Good evening, Zac. How are you?
Hey, Matt. I'm not too bad. Thanks for having me on here.
Thanks for joining us. I'm just going to pull up your slides and let you get started. I'll disappear, and we'll see you at the end of the presentation.
Okay, sounds great. Matt, thank you for that introduction. Normally a slide like this is at the end, but I figured a lot of my work was supported by commercial beekeepers and commercial beekeeping supported organizations, so we might as well start here. Like you said, I'm a visiting researcher at UMBC. I started the disease ecology lab here. A lot of this work was done at the USDA with support from NEFA, California State Beekeepers, and North Dakota Beekeepers. And a lot of the first work that we're going to show here was supported by Project APISM. Now also taking on a hybrid role in the industry. I'm the scientific advisor for Hive Armor Bioscience. And I'll get started now. We talk about Varroa quite a bit, and over the last few years, my work and my colleagues have added a lot of specificity to what that conversation looks like. So this talk is primarily going to be about these individuals down here. Because this is recorded and live, and we're just a tad behind on publication date, we're going to leave out this individual up on the top over here. We're going to start by talking about worker bees and drones. And the thing that I'm going to really point out to them that often gets missed is actually being shared here on these two photos. And that's that your mites feed on adult bees at very high frequencies. They do this because of this host switching behavior that we'll talk about. But the thing that's distinct about when they feed on an adult bee is those bees are asymptomatic for long periods of time. So you can see in both of these pictures, we're clasping those bees by their wings. and there is a mite feeding on the underside. You can't see this, of course, when you're working your colonies until you pick up enough bees. Well, those bees are parasitized. The mites will leave them, and they're going to walk around your colony for an undefined period of time as these asymptomatic carriers. So they're harboring covert infections. And that's going to be a real big bulk part of this talk. Now, this is a trite saying, who a vector bites matters, but it's essential to understanding what's happening with honeybees now. And we don't have to look very far until we find a wealth of information that can clue us into maybe some really important parameters of Varroa. And we have over here another vector, and a vector being defined as a biting arthropod that through its feeding is able to transmit a pathogen to a host. So the most famous are these mosquitoes, largely because they have, through their feeding on people, have shaped human histories. Now, you and me, when we're talking about mosquitoes or ticks, or in this case with honeybees, mites, we'll be like usually thinking like they're all the same instead of thinking of them as individuals. The reality is they're like us, where there's a lot of individuality across mosquitoes or mites or ticks. And some of the heterogeneities or differences between individuals can actually drive disease transmission. Laura Cooper in 2019 had this really beautiful paper and very eloquently showed that the host switching rate of mosquitoes drives disease transmission. And if you kind of want to think of it this way, if we were to go out fishing at night and we forget our bug spray, we might get bit by some mosquitoes. Now, some of those mosquitoes might be lazy feeders. They'll go out and feed on a couple of us, and then they call it quits for the night. Whereas others might be very ambitious feeders. Well, they'll go and feed on like 20 hosts in an evening. So you got these, slower, lazier feeders, and then these high frequency feeders. Well, those high frequency feeders are the ones most likely to feed on someone that's infectious and then subsequently vector a pathogen. Same thing happens in Varroa. Now, my animations aren't working here, but Varroa will move across your adult bees to feed. Historically, we've viewed Varroa maybe a little differently than how they actually operate inside of a colony. And there's three really distinct features if you go into the material and methods of older research papers. And the first one here is that it's a very brood-centric parasite. That's how we've studied it. If you go into the material and methods of a lot of research paper, we've procured mites from pupal cells to study research, or we've studied the bees parasitized during their development. The reality is that's a minority of the bees actually parasitized in a colony. And I'll talk about that in a few minutes. And so we've overwhelmingly focused on research during the development stage. We've also, both as beekeepers and a research community, focused on these morbid bees, featured over here in C. Now, that bee right there with the crippled wing stands out from every other bee in a honeybee colony. And beekeepers focus on it because it stands out. What happened was during its larval through pupal development, a mite parasitized it. That mite had high levels of virus in its mouth parts, and that virus was able to migrate to that developing pupa's brain, and it caused a morbidity. So that morbidity looks like these crippled wings, which gives the virus its namesake, deformed wing virus. Now, in my laboratory, this bee, we're not actually very interested in it. We don't study it very much. And that's because this individual bee is going to emerge from its cell. It's going to try to beg for some food, and it's going to die in a relatively short period of time. So it's a very poor candidate for secondary cases of transmission to nestmates in a colony. As a disease ecologist, though, I'm very interested in the bee standing just beside it. Now, this bee, especially if it's parasitized during its adulthood, it can develop very high levels of virus while living for a long period of time. That means it's going to have a lot of contact with nestmates. That's the exact type of individual that can cause lots of secondary cases of viral transmission just as it goes on through its life. So this is the bee right here, that asymptomatic carrier that my lab studies quite a bit. Now, early in the season, mite feeding on bees is predominantly on drones here. And then it shifts mid to late in the season onto worker bees. And I'm going to describe why that is over the next couple slides. So we did some pretty extensive work over 4 years with 2 commercial beekeeping operations, and then with experimentation in Maryland. And I'll cut to it. But what we found was that mites prefer these young drones. They move on them at pretty high rates to feed upon them. Now, we were able to figure this out experimentally by hand painting thousands of bees at emergence. So we have these age-marked bees, and we would check them every single day for a 9-day period, both workers and drones. And what we did was we'd give them these secondary and tertiary marks if they were parasitized by Varroa. And what we get is essentially this colony that looks like a painted up Christmas tree. And we know the parasite history of each of these individuals. And just to give a shout out, this is an intern, his name is Abu, who did this work years ago with me. And this isn't a rain day for us. Once we start an experiment, short of there being lightning, we carry through with it. Well, I want to talk about this for a second. So this is our data from 2 years of that hand painting work, broken down into a single bar graph here. My x-axis going this way is the age of the bees, while my y-axis is the percent of mites detected per host. And I've color-coded these bars. So we have orange, which are our worker bees or female, and that aqua color are males. And we can see by magnitudes that mites are feeding on these drones over their worker bee cohort. Now, for day 1, that's when a bee emerges. And we've already very well established that mites prefer drone brood. Researchers have already shown that, and that's why drone comb removal can be such an excellent IPM strategy. However, what wasn't observed is on days 2 and 3 of a bee's life, a lot of those bees are acquiring mites on those days. The mites are actually preferentially seeking out those bees and moving on to them. And when they have a choice between a young worker or a young drone, they feed on those young drones almost at a magnitude of 4 times as much as the worker bees. So early in the season, we would really describe this as mites aggregating on a smaller cohort in a colony, which is the distribution pattern that parasites normally form. Now, a thing to really point out here is your drones have one important job, and that's to mate with the queen, not within their own colony. However, within a colony, they don't have any colony maintenance tasks. They don't clean cells, they don't take care of brood, they don't take care of the queen. And when they engage in trophallaxis, they receive, they don't give. They're very poor candidates for secondary cases of viral transmission within the colony. So they're a great candidate for transmission outside the colony. And if you're a queen producer or replacing colony losses through queen cells and splits, then heavy parasitism on drones should definitely be a concern for you. But for the colony that it's in, its health, they're actually acting as a cushion, right? So mites are feeding on them, they're bearing most of the parasite burden, but we wouldn't necessarily see the effects of that burden on the colony health. And I'll also point out again, this parasitism is occurring, and these bees are just walking around as these asymptomatic hosts. Now, in my study, we have bees that over a 9-day period we've never seen parasitized. We color code those just brown for a schematic. And these fluorescent ones have been parasitized either during development or adulthood. So at the end of a trial, we actually have an idea of not just what the alcohol wash is, but actually of how many mites, or how many bees, I should say, were parasitized during that short period of time. Now, this is a big thing that gets missed by commercial beekeepers, and we want to remedy this story and start changing the narrative of how we talk about mite infestations and how we talk about treatments. And I'm going to encompass that conversation over the next few slides. We have 3 different figures or numbers down here. One down here is the relative parasite burden. That's my alcohol wash. That's how many mites per 100 bees. And for this colony on July 5th in 2020, it was 5%. Now that tells me a very small part of the infestation story of this colony. It doesn't tell me of those 100 bees, how many were parasitized, right? All it tells me is how many mites in that sample. Well, we handpicked up those bees for 9 days and recorded when we saw mites on them. The absolute parasite burden, so the number of bees actually parasitized, was greatly different between drones and workers. In that 9-day period, we saw 65% of the drones were parasitized. So they bear most of that parasite burden. Whereas on worker bees, it was 14, and it's covered up a little here. I think it's 14.3%. So what we see early in the season is those drones are bearing most of that parasite burden. And we should point out the number of parasitized bees is much higher than your alcohol wash. So conceptually, your colony looks like this early in the season, where a smaller cohort, your drones, are actually bearing most of the parasite burden. You're still going to have mites on your worker bees, okay, even in these infested colonies, just they're more attracted to those drones. And there's some consequences to this. Now, one of them is that these very large, robust colonies that we all like to take pictures of, these are your brood factories for Varroa. Okay. If I'm a parasite, I want to be in this colony because this colony has tons of resources. It has tons of drone brood, so I can reproduce in high numbers like mad. And you have a lot of young drones for me to parasitize. And these colonies, Mike Palmer was absolutely wonderful letting us use his operation. Now down here, his first 2.5 boxes, so his 2 deeps and a medium, that's his brood chamber. He runs this unobstructed colony, so everything else on top is honey. Now, everyone liked to take pictures next to these 2 colonies, and they were brood factories for Varroa. In fact, they were walking dead by August. And over the next couple slides, we'll explain why were they walking dead by August. And the thing that we should recap here is they are able to produce tons of drone brood. They want to invest in sexual reproduction. They're doing it. Those mites are taking advantage of feeding on both that drone brood and reproducing, and then feeding on lots of adult drones. It's not impacting the colony health at that time of the year, because again, drones aren't taking care of the queen or rearing brood, so they're not. It's not impacting the health of that colony. Now let's go back and talk about that reproductive and the non-reproductive phases of mites. As of now, those are the 2 life stages of mites. They enter these brood cells to reproduce, or they're in a non-reproductive phase where they're physically on adult bees. We used to call this a phoretic stage. Now, when a mite enters a brood cell, it's going in there to reproduce. And that mite is temporarily imprisoned in there while it's in there to reproduce. And the big takeaway here is for that 12 to 15 day period that it's capped inside that cell, there's 1 mite for every 1 bee. So the ratio is 1 to 1. Okay. Now it's going to exit with more mites, but while it's temporarily imprisoned there, 1 mite per 1 bee. It's a very different story when they're on your adult bees. When they're on your adult bees, they're on there for a variable length of time, but they switch on average every 2.5 days. So for that same period of time, they can feed on up to 5 adult bees. In the same period of time, they could be in a brood cell. So there's a few important takeaways right here that we should pay attention to. One, we're always going to have more parasitized adult bees than we'll have parasitized brood. So if you're starting to notice bees with deformed wings or cannibalized pupa due to mites, think of it this way: you have that many more bees that you're not seeing that are actually getting parasitized. The second thing is you always have more parasitized bees than you do mites in the colony. So if the ratio is always 1 to 1, then that comment wouldn't stand true. But the fact is, because they're mobile, moving from 1 adult bee to another adult bee, you always have more parasitized bees than you do mites. This becomes a really big problem later in the season when mites shift from those drones onto the workers. And this is supposed to be an animation. It's not working. We'll just ignore it from now. And we want to imagine what happens in the middle of the summer when we hit these dearths, and it's going to be variable depending where you are. In Maryland, we're probably going to hit a dearth well before you all, unless if you have a rainfall issue, right? But in a lot of places, it's usually sometime in August we start to hit these dearths, and our colonies stop investing into sexual reproduction. Well, by that point, a lot of them, if we don't have treatments on the colonies during that spring and summer period where the mites are building up, suddenly you're going to have a slowdown in the availability of drones, and suddenly mites shift very dramatically over the worker bees. There's some pretty big problems when mites shift dramatically over the worker bees. So these three figures come from a paper from 2024 that we published in the Proceedings B. And the big takeaway here is we have this very fluid virus, deformed wing virus, and some of the paralytic viruses that can move in any which direction amongst members of the bee colony. So deformed wing virus is the model virus we used in this paper. We showed that it can move from mite to mite. When we have an infectious mite enter a brood cell with a naive mite, they both leave as infectious. And if you're not familiar with that term, what we mean by naive is not all of your parasites, whether they're mosquitoes or ticks or mites, have high levels of a pathogen in their mouth parts. So for example, if we go back to that fishing analogy, we could go out fishing and get lit up by mosquitoes, forget a bug spray, we're not going to die the next morning, right? And that's because the mosquitoes biting us are going to be naive. They don't have a pathogen in their mouth parts. Now, when you get a West Nile virus announcement in your area, it can be a very different story. Because if a mosquito with West Nile virus in its mouth part bites you, you're going to have a high likelihood of getting sick. Same thing happens with the mites. So when mites share a same host, whether it's adult bee or a worker, you can have essentially a clean mite feed on the same bee as a dirty mite, and they both leave dirty. So that's the mite to mite transmission. Your bees, we've bred them to cannibalize pupa, to uncap, detect mites, and in that process, they cannibalize pupa. Now, this is fantastic. We want to have bees with high Varroa sensitive hygiene. This also helps with other diseases, but there's no free lunch in the biology world. There is a consequence to this. If those pupa develop high levels of virus, then the cannibals, the adult bees parasitizing those pupa, can become infected just by chewing on their brood. Mites that feed on those cannibals acquire the virus and then transmit it. So one of the things you don't see going on when you start to see more and more mites later in the season on your worker bees is that viral amplification that is starting to occur. And it occurs for a period of time where it's very asymptomatic. So viruses are increasing in abundance in your colony, but you're not going to see it. And these are some of the circulatory pathways that it occurs. So the viruses can go from bee to mite, of course, mite to bee, and also mite to mite. Now, this is that same colony from July, and this was in August 6th in Maryland in 2020. So Maryland is this mid-Atlantic southern state. We hit a pretty reliable dearth before lanternfly landed here. And suddenly our colony doesn't have much in the way of drones anymore, right? But those mites still want to feed. So I'm going to be brief so I don't go up on time. And I'm really excited to talk to Ian, Matt, and Phil here as a conversation afterwards. But think of it this way. You're pulling honey supers. You know you're in a dearth. In your head, you're wondering, how much pollen sub am I going to buy? Should I buy probiotics? When do I add a treatment? Your mites who have built up during that period of time that you've had honey supers on. So suddenly when there's fewer drones for them to feed on, they're not going to suddenly go on a diet, right? They're not going to go on a Jenny Craig diet and then not feed. They're going to shift onto worker bees. And they shift in a pretty dramatic way. So this colony was 14% parasitized the month prior to this experiment. When we redid it, suddenly 60% of the bees, the worker bees, are parasitized in a 9-day period. And this is the thing that I don't have a way to describe the magnitude at which this happens to your colony. And it's very nefarious for commercial beekeepers. Mites will literally bite up almost the entirety of your colony in a short period of time. They're doing this on the day and week level, whereas often many of you are treating on the monthly level, especially if you only do these seasonal treatments. And the most nefarious thing is what they're doing to you. This is what 60% parasitized looks like. So this is that experimental colony. The honey supers are off. I'm not going to win any blue ribbons for this colony, but everyone has colonies that look like this in their operation. And this, and I keep saying this, the word nefarious, this is the most nefarious thing mites are doing to you. They build up on your drone brood and your adult drones. They're not causing any damage. Drones slow down. They suddenly shift onto your worker bees, and they bite your bees one day, but the damage is not observed for weeks later. If mites bit a bee and suddenly we saw the damage, we wouldn't have a Varroa problem. We'd know exactly when to treat the colonies. The problem is they're going to feed on this, the entirety of this colony, and I'm not going to see the colony dwindle for a long period of time. And that's because these bees are able to walk around as asymptomatic carriers, even though they essentially were just delivered a death sentence days to weeks prior. This is another heavily parasitized colony. This is like 40-something% parasitized. You just can't see the effects of it yet. So we need to start rethinking how we approach Varroa. And I'm doing over here on the left what all of us do, which is we take an alcohol wash, we shake it real quick, we put it up to the sky, and we essentially want to know, is it low or is it high? And for me, mediums are high. And I'm here to tell you we need to rethink actually how to do that, because this alcohol wash was 14.1%. That is this 60% parasitized. So when you see this, what actually has to go on in your head is this over here on the right. Okay, so these high alcohol washes are actually equating to all of your worker bees are parasitized. And I get calls all the time about how to fix these colonies. And that's a fundamentally bad question, right? Well, I should say it's a poor question. It's not a bad question. And it's because it's really difficult to fix these colonies. To some extent, you're going to have a poor outcome no matter what you do on some level of these colonies. But a far better question is, how can I have prevented this? Or how could I predict this from occurring? And those are far better questions. How can I go back 2 to 3 months and manage Varroa to a point where I won't see this occur? And we are starting to see that this is where the industry is going, because we're seeing companies produce multiple products with some similarity in their terminology. And this is a new treatment paradigm where our conversation and Varroa biology needs to catch up to it. But we're seeing companies start to do this, where we're seeing products come out that offer months-long protection. And they're being applied from spring through summer, so that they put heavy downward pressure on the mite's ability to reproduce. You see this in oxalic acid slow release, or you see this with Varroa. To some extent, Apivar 2.0, where they really designed this so you can put it on early in the spring, get a knockdown, and then this extended treatment. I'll bet you have to take that off before honey supers, right? So these are different than flash treatments, where you put an active ingredient in the colony, it knocks down mites, and then the active ingredient's gone. Instead, with something like Varroa or oxalic acid strips, what you're doing is you're putting it in, that oxalic acid or some other AI stays in the colony for a long period of time. And instead of mites ever building up, you have this heavy, heavy downward pressure on their ability to successfully reproduce. And the big goal here is what I have in bold. It's where you enter the fall, where your bees are not impacted by Varroa and viruses. So I know that's partly where we're going. Matt, I went over on time, so I'm going to flash through a couple things just because I know they're going to come up on conversations. And I'll be really brief here, I promise, because I'm really excited to talk to the guys that are on here. But we have this issue with alcohol washes, where early in the season, lots of people are getting zeros and no detections. And what we did at Mike Palmer's and Troy Hall's is we did alcohol washes, and then we paired it with hand picking up worker bees and hand picking up drones. I think we picked up something like 33,000 bees. Long story short, we see this same trend when we pick up bees at random, where early in the season, this is May over here on the left, we get very few detections. Most of those detections are on drones. It increases as we progress through the summer until July, where we get more and more detections. Most of those are on drones. Then in August, we suddenly hit that summer dearth, and suddenly it's almost like mites don't prefer drones anymore. We know that's not true. It's just suddenly hit the dearth, there's fewer drones, and they shift onto the worker bees. This is our alcohol wash data, and it follows that same pattern where we get very few detections early in the season. Most of them are low, and then they spike in August when mites suddenly shift from drones onto workers. Now, Matt, I have too many slides, and I want to be very respectful of time here. This is probably a great part to step off of me giving a presentation and then enter back in with everyone else.
Sure, sounds great. I will add everyone to the screen here in a moment. I just want to thank you for that excellent presentation and the handpicking of bees. I mean, I can't even imagine just the endless work that you guys, your team, and others have put into this. So thank you for both of those. I'll add everyone to the screen, and then I'll just kind of get my words in here before we get everyone else started, because I don't think I'll get a word in edgewise for the rest of the night. I think we're going to have a lot of great questions and discussion here. So, but I just wanted to set up a bit of a challenge for you here, Zac, that I feel is coming. We're talking about here in Manitoba, a very intense season, very short. And so when we're doing any type of early treatments, people will pull their bees out of an indoor wintering building around April 1st, give or take. Overwintered outside, you could kind of start making rounds and putting in apivar strips, typically mid-March, I would say, just a general rule of thumb. So that's when the treatments would start. And I think these guys will do a much better job kind of describing the challenges they face in the field with treatments. But essentially what I'm thinking is you have demonstrated this critical shift over between, when the mites are becoming the most detrimental to the colony, and when we need to sample and treat and intervene, and determining better treatment intervals, if I'm catching that. So that's kind of the direction we're moving in. And you've also noted some of these paradigm shifts in that knockdown to the long-term protection and all that. So I do kind of have maybe a question about general alcohol wash treatments. A lot of beekeepers will go out and they'll check for an alcohol wash, but they end up needing to treat anyways. So it's not telling them to treat. They already have their treatment scheduled, right? So that's something that I've heard a lot about. Some beekeepers saying, I'm doing alcohol washes, but I'm not actually changing what I'm doing because my timeline is so tight that I'm doing everything I can, basically. So I'm just going to kind of describe some of what I've heard. That's a description of some of what I've heard coming from the field to kind of set you up. Maybe the guys will tell you that's not entirely accurate, but yeah, I'll just kind of open it up to them. And I hope that gives you a bit of a description of our treatment regime here. If anybody else wants to jump in and clarify what I've said, maybe that'd be a good moment. And jump in with your first questions. Go ahead, Phil. Oh, Phil's on mute. Let me see. I'll take you off mute. There we go.
Thank you. Thanks, Matt. Zac, I enjoyed your talk. Explains, and good science explains what you see in the field, which is, we have, you do your sampling and your treatments all spring, and you think, wow, I've got things really set up well, and then Labor Day comes and suddenly you got a disaster on your hands. And lots of us have been through that. So this understanding the shift from the mites aren't where we're looking in the spring to suddenly than they are on the workers after the end of the honey flow, that makes a lot of sense. And I'm trying to maybe do the math on that a little bit. So just looking at the numbers I had, like when you do there's fewer drones than there was workers in that hive. You were painting every hive. You had 4-to-1 mites for mites on drones to mites on workers was 4-to-1. but there's a third less drones than there was workers. So I've got that as a 6-to-1 ratio. Does that make sense to you?
Yeah, if it's online in the supplementary, what the ratios were for each of our colonies,
Okay.
and I'm going to misquote if I try to remember those specific numbers, but I believe the average is around like 4.5 or so. But
Yeah,
that's
you
from
said, yeah, you had for mites on drones was 4-to-1 to mites on workers. But then when you actually, it's also skewed the population, right? That there's more workers than drones.
Yep.
So if it was a 50-50 population, it would be 1/3 more.
Yeah, unfortunately, so we didn't do population dynamics, and in fact, I feel I stayed away from it because of how
Okay.
complex it is in a honeybee colony.
Yeah. Okay.
If you think of it, your old drones aggregate on the outside of the colony. The young drones do migrate to the center to beg for food. You have drone brood that's going to be different in number across colonies. And in fact, there's a ceiling on how much drones your queen can produce just based on availability of cells. There's an almost endless amount limited by our egg laying capability for workers. So we did this by sample instead of trying to do the population dynamics.
Okay.
I think we tried not to get in the weeds from it, but the practical thing was there's more of the burden falls on the drones early in the season. And what's missed there in those numbers is some of those drones would have up to 8 mites on them.
Yeah.
So they're actually attracting quite a few of those feedings.
So how would someone go about sampling their drones?
Yeah.
In a mid-spring going into summer kind of situation?
Oh, that's a great question. So we haven't published yet, but what we do is we use an open container of alcohol, and we hand pick 40 drones in the center of the brood nest.
Mm-hmm.
And I use this as now in my operation as a predictor because I'm not interested in when an alcohol wash tells me that my house is already on fire. It's like, okay, thank you, not super helpful, especially with this information. If your house is on fire, it's literally parasitized, all bit up. But early in the spring here, when I sample 40 drones from the center of the brood nest, if we get multiple detections here in Maryland, 100% of that time that colony is heavily infested come fall. From a practical standpoint, would I rather manage those Varroa then or take a $200 or risk taking a $200 loss in the fall in terms of colony loss? So for me, I split treat and requeen those colonies because I'd rather get $600 worth of splits out of that colony when it's not impacted by mites, treat it and give new queens an opportunity to show me they can keep mites down. I know for you all, especially like Ian there and others who are sitting behind a lot of equipment in your backgrounds, the idea of going out and hand sampling drones probably has some level of ridiculousness there. So what we're also providing as like a service that I'm doing through Hive Armor is we'll do these deep Varroa dives in commercial operations on a large sample in someone's operation. We're doing an alcohol wash. I'm actually hand picking up mites hand picking up newly emerged workers. I'm hand picking up drones and inspecting them, and then we're quantifying damage. We can actually give someone a scorecard of where they are in the disease cycle and how infested they are. And as a service, that's actually really valuable to someone because you're all going to have mites. Everyone's going to have mites. We're not going to get rid of them. They're endemic. They're an incredible parasite. Our goal is to manage them so that when we approach winter, our colonies aren't impacted by viruses and mites. And so we're using this now to give scorecards where if someone has, let's say, mites only identified on low levels of the drone and we're not seeing it in the newly emerged worker, we use that as an assay for brood or worker brood, and we're not seeing it in the alcohol wash, that's where you want to be. Essentially, mites are at such low levels, they're not going to be impacting your colony health. It's where we start to score it with damage and detections in the worker brood that you have a big issue that you need to take care of right now. So when we can kind of give that general guidance in the middle of the season, that's really helpful for a beekeeper.
Thanks, Zach. I'll turn the floor to whoever wants to go next.
Yeah, I was just going to say, just what you're saying there, Zach, is really important. In the spring, I find a lot of trouble. Well, we're shaking. We're shaking zeros. We know the damn things are there, but we're shaking zeros. I'm just wasting my time, So then what do we do with the zero information? We know the mites are going to build, and now you're talking about the shift later on in the summer. But I need that information on what kind of severity I have in that spring, so I know how hard to hit them and how many times to hit them, because I want to. And if I don't have to, then I don't want to. Would it be, from what you're saying here, if I went in like right now and started picking drones instead of allowing workers into my wash, and let's say I had 40 drones in there, what would I find? Would I
Well,
find like a wash that is more reflective to, from what I'm gathering, it'd be more of reflective to the population of mites in my colony, right? Instead of washing workers. Do you see kind of what I'm getting at?
I do see what you're getting at. We haven't figured that out yet, and I should jump all the way back to work from the 90s where Calderon did repeated alcohol washes on a single colony, and that result varied widely. We don't necessarily see a pairing between infestations on the drone and what the alcohol wash is, and unless if I'm missing your question right there.
No, carry on. Yeah,
okay.
Follow with that.
Yeah, but if you were to go in and sample drones right now, here's what I would suggest actually is always do an alcohol wash. It's how we know to communicate to each other and how we communicate to Mac and your tech transfer team, right? So we don't throw the baby out with the bathwater. We still want that. But if you were to go in from the center of the brood nest and start sampling those drones, you're really looking for high or low, and you're trying to sample multiple pallets so you get an idea broadly what your whole yard is. This is because parasites form aggregated distributions. We all have been talking about it for years. We just haven't put it in terms as a parasitologist would. I think you all have hotspots in your operation where like a whole pallet, like everyone's zeros and then a whole pallet's just really high, or everyone's low and then one colony's really high. That's actually a natural distribution for parasites where everyone has nothing and then suddenly everyone has everything. Those hotspots are actually natural. What you don't want to see, Ian, is going out and in every colony you're sampling, you're seeing mites on drones.
Yeah.
Because when they're evenly distributed, it's actually heavy pressure on your hosts. I think I missed your question a little bit.
Well, yeah, I'm just trying to figure out a way as a beekeeper in the yard to figure out what my severity is within the yard when we're dealing with such low mite counts in the spring. It's almost indetectable. Like if we're shaking 0, 0, 0, we find one, but there's still the mites that are within the colony that are going to fester into something that causes trouble later on in the fall. And if I'm seeing zeros, I'm getting complacent, and then I'm not going to treat, and then it's going to explode. But if I could, find a more accurate way to determine more what is my situation, I'm just wondering if just sampling the drones in my washes would provide me with that information aside from washing worker bees in the shakes.
Gotcha. So now I have a far better idea. I would jump in. The first thing is, because I'm finding this as I do more and more direct field service for beekeepers, we're all worried about mites. We need to focus on them. They're not the only issue in an operation. And sometimes we get into operations and there's other things going on other than mites. I think the first thing is making sure that we can set aside that in colonies there isn't something else going on. Then when we jump in and look at, okay, I'm getting all these zeros. If that's happening where you're not getting detections on drones, you're not getting detections in your alcohol wash, I go that extra step and literally can pick up when I do a service newly merged workers, because we want to give you an idea of how much they've already infested your worker brood. When we're not seeing anything there, fantastic. We know we still have mites in there. They're incredible at reproducing. But then at that point, we're not worried about them. What we want to do is actually apply a treatment, though, at that time. That's this long-lasting treatment, so they never have the opportunity to reproduce at levels that are going to negatively impact your colony health. If you buy into that paradigm. If not, we're really falling back on an older paradigm where we're only interested in applying treatments, or we're applying treatments when we start to see mites come up in numbers. The problem is that shift can happen so quickly, and it happens right at the time of the year when you all get really busy, usually pulling honey supers or doing something else. So I wish I said it in the video. If we see a heavy mite fall, that's not very exciting to me, right? The very exciting thing to me is there's some active ingredient in the colony at a low level, and you never see a heavy mite fall, because that means you have bees that aren't impacted. But Ian, I'm really sorry, I don't have a great answer for you there. Oh, the second thing I meant to say is we really have to, at least here in the States, we really have to figure out a better way to battle mite emigration from colony to colony. When we have these crashing colonies, they can send thousands of bees, not just to your neighbor, but to the pallets next door. And I'm starting to do in my own operation, so I have some photos to share later in this year, and also from some other people, whole colony alcohol washes. These are colonies, by the way, that we know are shedding bees, and they're going to die. Like, we're not just going out and shaking the whole colony because we're sickos, right? And we'll shake them and find a few thousand mites in those colonies. They were going to end up on the pallets next door. And Ian, if you have a way to identify colonies that are going to crash and remove them before they do, you're going to be a better beekeeper than me, by far. And you're just going to prevent so many of your healthy colonies from getting seeded very heavily. Sorry, I went off on a tangent there.
So then that shift in the summer, when the drones shift from the mites shift from the drones to the workers, when would you say that happens? Do you say that happens at the time when the queen quits rearing the drones and there's no fresh drones being emerging anymore, and then the mites will then, they don't want to hang out on old drones, so they go to the worker bees? Or when does that shift happen within the nest?
Yep, it happens as the abundance of young drones starts to disappear. So it's very quickly after she slows down her egg laying on drone cells, and it's going to be a little variable based on your colonies. So, for example, here in Maryland, we're weeks ahead of you. I already have colonies that started out with a few mites on drones early in the season. They built up, got about 60 pounds of honey from them, which is good for our area, by the way. And they're already declining. They're going to be crashing, shortly. That's not because of seasonal drone production. It's just mites were higher in them, and they already impacted the health of the colony. But so you'll have some colony level effects from mites, and then you'll also have that seasonal level as soon as they start producing those drones.
So it's basically at the time when the young drones quit coming out. Those mites want the young drones, is what they're looking for. Yeah, it's not when the bees start kicking the drones out the front door because of winter. No,
weeks prior. I think for a lot of us, it's I keep using the word nefarious. Man, you're out there, your crew's out there, you're pulling honey, and some of you all are looking down trying to see where are you for mites, right? And on a bad year, it's already shifted as you pull that honey. And you know what it's like, because it goes on in your head. You're like, oh man, this is bad. And some of you all stop pulling honey or stop processing your honey frames and just start treating right away because you want to get ahead of it. So way before kicking out drones.
When would you think that would be, Phil, in our area then?
Probably
middle of August, maybe?
10th of August, probably.
Yeah, probably not too far after the August long weekend, I wonder.
Yeah, you're probably your whole second round. The drones are slowing off.
Yeah, that brings up, I know, Phil, you mentioned to me, and I think everybody kind of goes by this. You're getting the final honey off typically at the end of August, depending on your region. And you got a little bit of time to do your mite shakes, right? It's September long weekend, the first week of September, and you're trying to figure out how serious is this issue right now? Like, where am I? Because I've been flat out pulling honey, getting my stuff extracted, But from what I can hear, this date you just gave, August 10th, it kind of gives a shift in perspective of where you're looking for the seriousness of the issue. So instead of trying to figure it out on September 1st, you're already kind of thinking, how do I get noticing by, paying attention to Zach's research by August 10th? Is that what you guys are kind of talking about here?
Well, I'm doing my mite washes middle of August. I'm wasting my time then too because I'm shaking zeros. I've said there's nothing coming up in that, and either they're hiding in the brood or, like what is being said here, there's like 65% of them are on drones at that time. That's what you're saying, right, Zach?
I'd have to look at the paper and what that exact number is, but
that's what I wrote down, 65.
Yeah, so that means our washes are not telling us the truth because they're all on the drones. And it's not until they shift off the drones on the workers that actually does show up in our washes. So it's not necessarily that the mites are hiding in the brood, is maybe they're just hiding out on the drones. That's kind of what you're saying, right?
Yeah, it is. And there's also several, I mean, Randy Oliver did a good job bringing this up too. And if you look at older research papers, others have brought it up as well, where your brood is just such a huge reservoir for mites, and it's not equal across colonies. But what happens as we get closer and closer to late fall, our colonies become more homogeneous. They have far fewer drones and they have less brood. That's where the alcohol wash is going to be a very good tell for what's going on in your colony. The problem is there's no runway in September to winter. You just lost, you're sitting on the tarmac, you have no runway ahead of you, right?
Yeah.
So if you have a problem, if your house is already on fire, it's very difficult to remedy that. And I think instead of necessarily putting on it a hard date, because colonies will start failing at different times, I think a better question is like, how can we systematically control Varroa so that we're not having crashes contaminating our healthy colonies within our own yards? And how do we approach those middle of August through September dates so we have colonies that aren't impacted by mites? And I think we're going through this evolution, and we've been going through some time, and we see some really successful beekeepers starting to shift there with some different strategies. And we still have some beekeepers doing really well with a knockdown in the spring, knockdown in the fall. We have some that have shifted to those long-term treatments. I think the biggest benefit to something like that is it frees you up to actually do the beekeeping you actually want to do. For me, I'm going to keep doing research. I love doing it. I love doing the extension with beekeepers. I want to get back up to where I can have a couple hundred colonies and it just doesn't kill me with my schedule. And the only way I can do that is if I stop running around, constantly having throughout the whole summer worry about mites, right? I want to get back to nothing but queen breeding and pulling honey supers. That's the fun stuff. And instead, we've become these Varroa farmers where we're constantly trying to amend for Varroa viruses, Varroan viruses.
I would add to that, Zach. I think there's a silver lining here, which is some of us, we do those shakes in Labor Day weekend or at the end of your honey flow, and you're like, holy crap, how did this get away from me? And you end up beating yourself up and you question everything you ever thought about being a beekeeper. Because, like in my own case, like 9,000 bees have been through the shaker in the last couple of days, found 6 mites. And so, like, at least in the old days, I would just rest easy and plan to have a good crop. And now, but then it could easily be that when I go look at the fall, I suddenly have a 5-alarm fire. We probably should be planning for some, long-term control right through the season, and hope to have low numbers in the fall instead of just waiting to see. But I think as we should probably give ourselves a little bit more credit on, we did what we needed to have zeros through the spring, but that is no guarantee of zeros come September.
Phil, I agree with that. I think you put that very eloquently. I want to shoot back a question to to the 5 of you on here. In the States, I'll ask beekeepers this generalized question. If you have 10,000 colonies on January 1st, how many colonies do you have to make throughout the year to have the exact same number on December 31st? And I'll get a response usually between about 33 and almost 70%. And I'm curious if it's similar for you all in Canada.
Yeah, I would say 30%.
Yeah, same, 30%.
Okay.
Say
Ian,
that.
about-
Say that again.
What's your
say
attrition, Ian?
my attrition through the entire season, right?
Yeah.
Well, like, if you look at winter, let's say you're getting through winter 20%, and then take another 10% through summer, and then take another 5% maybe.
Oh, it's how many colonies do you have to make just to stay even? Yeah.
So that's 40% or 35-40%, I'd say, just to hold the number. Then if you have a bad winter, then you're looking at closer to 50%.
Yeah, I'm the worst beekeeper here because I would target 50%.
Yeah.
You know,
I'm
that
sorry,
probably on average would give me a little bit of margin, but safety margin.
Yeah. Well, the reason I posed that question that way is, one, that's how I can describe to a policymaker how difficult it is for commercial beekeepers to keep going. Because they see, media reports on bee losses, and it happens every year. And what I describe is very different, which is you all have gotten incredibly good at recovering from your losses through splitting and making queens. And you've been able to produce enough colonies to stay even. Many of us have to buy in colonies, but a lot of you've been able to stay even. But there's also some hidden gems of information in there. If I use that pose, that 10,000 colonies, how many do I have to make just to stay even? You've in some way already told me. So also that just describes how expensive it is for you guys to keep doing what you're doing. But in some ways, you've already described to me that you have too many mite crashes in your operation. We can make a pretty good assumption that a lot of those are from mites. Matt, do you mind if we quickly share the slide again while keeping everyone on, just to show the next picture? So this is my colony, and I said I started doing whole alcohol washes, and these are for demos, right? This colony right here, I took the honey supers off, and it's just 2 double deeps. You can see that's the adult bee coverage on that frame. It's not very dense, right? What's happening is it's losing its adult bees, both through them cannibalizing pupa and bees dying quicker than the queen can and brood rearing can make up for that attrition. So it manifests as these big colonies with very low density of bees. We've done experiments on colonies like these. They're horrible at rearing brood, right? So we're going to eventually see this crash from this colony. Now, before this colony crashed, what I did was I shook it all into a Rubbermaid full of alcohol, and then let it sit overnight, sieved out the bees. I actually have to finish doing all these alcohol washes, these whole colony washes. But we're getting about 4,000 mites in these colonies. They're already actively shedding bees. When this thing crashes, it's sending those mites to my pallets right next door. We're blaming everyone else's neighbor. Every one of us is blaming a neighbor. But if we're having to make 30% extra colonies and they die in the summer just to stay even, those are our essentially mite bombs in our own operation seeding our other pallets. And I think one of the best questions we can ask Matt, Ian, and Phil, and others is, how do we systematically manage Varroa so we reduce the number of crashes in our operation? And I don't have that answer. I do not have that answer. If I did, I'd be much, much wealthier, right?
Yeah, gone are the days of Apivar efficacy where you just drop a strip in the spring and then did my job for the year. It's gone to 2 strips, and then now the 2 strips don't work. So then we're wasting money in strips. Now we're going to organic treatments, and if anybody's having trouble with the weather and organic treatments this spring, it's Manitoba beekeepers is like, we need the weather to do it. Too cold or it's too hot. Now we're running out of time. Like, geez, it's not easy. I'm going to shift into a long, like a oxalic acid extender strip, I call them, through the summer, and hopefully that does something without killing my colonies or compromising my honey production. But it's just like we're a bunch of mad scientists here just kind of dabbling, trying to figure out the solution, and nobody seems to be able to get it up here. It's really frustrating.
Zac, if I could ask you a little bit about just in terms of avoiding crashes and identifying maybe mite bombs and doing something about it. What is your experience with putting down sticky boards and, like, let's say doing formic flashes or oxalic and looking for those mite bombs and drops and identifying how does that compare to like other sampling methods and trying to prevent crashes?
Yeah, it's such a good question. When I do deep dives for other people, I'm not relying on sticky boards, usually because I'm flying in, sampling for a couple days and then leaving. Instead, I'm using other indicators for colonies that have an issue. The two that I look for right away is the adult bee density, the coverage on the frame. And colonies that aren't impacted by mites generally have really high adult bee density. When I open up a colony and we see that they're trying to cover this brood area with like half the number of bees that's there, I immediately go in and look for a chronic brood disease, which often manifests as this cryptic brood disease, right? And we have to do molecular tests to identify it, or mite damage. And then I'm looking for secondary things to describe what mite damage is there. So if we see repeated uncapping of pupa from mites, okay, there's a great secondary indicator that this colony has an issue with mites. We're either very low with mites or everything really should be considered high, because all of our mediums become high in the season, or those mediums. I think I'm sorry, I'm horrible with names. You have this excellent researcher that showed 1% in the fall or something is a threshold in Canada.
Dr. Nuria Morsha.
No, it's excellent work, right? So when I see some work like that was well done and vetted, then you have your lows and everything else is essentially high. So if we see two different indicators for damage, loss of adult bees, and then let's say lots of uncapping of pupa, then I think that fully answers essentially your question. I don't, we'll do the alcohol wash to describe that colony. I'm not going out of my way to look for how many mites drop from that colony, or how many mites are going to drop after a formic. I think for a particular colony like that, the better question is, how could I have gone back a couple months ago and prevented that? Because by that point, that colony is all bit up. When we open up colonies and we don't see young bees, that's something, again, that we're really concerned about, especially if it's a chronic brood disease. Here, we're getting a lot of cryptic EFB or cryptic chalk brood. And I hate those because you'll get these right-skewed colonies where they're cannibalizing so much larva that very shortly all of your adult bees become older. And, oh, you're stealing the show. That is just gorgeous.
Sorry. He gets what he wants.
Oh, I can hear him through the mic. That's gorgeous. Same thing with mites. If I have a heavily infested colony that the worker bees the brood has been damaged by mites, it'll often manifest by very few newly emerged bees emerging. That's a very visible thing that you can train your crews to identify. But you all are managing colonies on the system level, not the individual level. Ian, Phil, and I'm sorry, I'm horrible with names. It's going to take me, the two other gentlemen, a second to learn your names. But you are all the experts to start to transcribe this research or translate this research into how to manage on the systemic or the systematic level.
Yeah, Naz, did you have anything you want to add? You've been pretty quiet, but I know I was out at your place and we were talking a little bit about sampling and also.
I know I was kind of listening because it's very interested, but maybe question is, it's like Ian said and Phil said, we have such a hard time to find any mites until it's too late almost. Especially this spring, I went in end of February, most of my bees wintering outdoors, and there would be end of February little patches of brood. I brought, I can't remember, but about 10 to 15 frames of those home. And I've been sitting till midnight. I was opening all the cells and I couldn't find those mites. And it's very hard. Like, where are they? Why we can't find them?
I would say if
There's
you
no
are,
drones. There's no drones in the colony.
yep.
So
If your colonies are at that point where the mite level infestation in your brood is so low that you're detecting them on essentially an infrequent level, 1 out of 500, 1 out of 1,000, that's not impacting the colony health. I think a better question is, what do I put in the colony to protect it from invasions? Because if I have colonies like that, right, I want to maintain them at those mite levels. So how do I protect them from invasions? You're not going to do it with a flash treatment that just disappears right away. Because I treated on Monday, my neighbor's colony or another colony crashes on Wednesday, it's going to get invaded. And then the second is, what can I put in that colony so we keep that downward pressure on mite reproduction? So from now, you got your runway from now until September, that colony continues to grow with healthy bees, not get impacted by mites.
yeah, I got it. I understand, but still, it's challenging though. Like even when we get in now into this extended release oxalic acid, it seems it works. Don't get me wrong, it's working, but it's affecting in our area. I think it's affecting colony health for some reason.
In what time of the year do you think it's affecting colony health?
Well, you have a good colonies going whole summer, and all of a sudden, I think it's affecting its overwintering ability.
Gotcha. I think Phil's ready to perk up with an answer there, and I have one too. But Phil, do you want to jump in? Because I can already see the gears turning on there.
Well, I mean, I've been playing with trying to use the Roxanne strips when there's no drones, there's no brood in the hives, and it's hard on them. So, and Matthew's been part of that too. So, whereas I think you can hit them with a vape, and they don't seem to mind that very much. But that doesn't have that prolonged effect. I haven't used those strips much in the summer, so I would be open to what other people think about that.
Yeah, I mean, and that's when they've been primarily tested in Canada, only in the summertime until our, a couple recent experiments, including Marisville. But yeah, definitely that's the time they're the best for. I know there was a lot of concern this year with weaker colonies, just compromised by our long winter and tough spring conditions. People were putting the oxalic strips in, let's say in April, very cold April. Weak colonies got weaker, a lot of dwindle. The strong colonies barely held their own. So just that whether the oxalic strips were having, a detrimental effect by putting that acid into the hive when the colonies were just struggling to keep chugging along in April, when it's like, 10 degrees, 12 degrees most of the month this year.
Yeah, like last year I did some experiments with the oxalic, and then I've been putting it in end of May. And this year we are almost end of July, and I still hesitant should I put them in or not, because we have no weather. It's like 12 degrees today and wet and moist. And
Yeah.
Yes, did you put them in through the honey flow? Has anyone done that?
Yeah, I have done it.
What does that look like?
Working very good. I had hard time finding mites. Like bees in the winter were going in very low, but I think it affected winter survival ability on bees. They came out of winter smaller than they should.
And when did you remove those strips, Nez?
I started removing them, I say, end of August throughout the middle of September. But the problem is with those strips, it's very challenging to remove them all. As bees would chew them, and then you would basically you would think there is no strip left in the hive, but true story is it is there. Basically, to remove it 100%, you would have to tear the colony apart, pull every frame, or at least those frames where those strips were hanging down. But I'm still finding the strips inside.
Yeah, I have them in my colonies now, and I'm going to have my last date to put them in is middle of July. and then they'll come out end of August. I'll put that strip in. So at middle of July, when I put them in on my phone, I'll already have a scheduled date when they have to come out. So it just fits into my management. And so I'm running them right through the honey flow. And what I like about that is the way I make colonies here is as our flow starts to taper down, we pop off the honey super and then just condense that, what will be that wintered colony right down to a single. And I just pull nukes off of it. And I love it because these are nukes with really low mites and lots of adult bees. And we just add new queens to them in a new yard and populate a new yard. And then I'll eventually show up and pull that honey. And then I'll pull that last strip. So I like that running. What's that?
In our commercial operation, it's very challenging to do this too. It's very easy to say it or think about that, but let's say my first yard, first box is coming off mid-August as a treatment coming off or new treatment coming in. But the last yard, it would be middle of September. We'll have a month difference, you know what I mean?
Yeah, that's where, but there's no runway in September. Even down here in Maryland, I don't have runway in September, and our weather is so much more amendable. And that's where I think you need to backtrack that up by a month, because we're really doing our last things in.
Because if you have those thousands and thousands supers on your bees, well, you just can't pull them all in once. You just can't see.
I found you need to integrate the first post harvest mite treatment with the box coming off.
Yes,
the box comes off, the treatment goes in, or you're never going to get caught up.
That's what we're doing, but the thing is, first box would come off in mid-August, last box would come off end of mid of September. You know what I mean?
That's a bit of a natural experiment. Do you find better results on the hives that get pulled first compared to the last ones?
I wouldn't say so, no. They look all good to me the same way.
And was there a difference in how they wintered this spring?
No. It was so like a shotgun, you know, it was everywhere. It would be 1/4 of colonies would on the same yard good, quarter weak, quarter that, stuff like that. It wasn't be like, you know, half of operation strong, half of operation weak or that. It's all over the place for some reason this year.
Right, but that's telling me that the timing isn't the critical factor there then.
Not so much, and I wouldn't say not so much, no. If you
Zach, sorry, Naz, I stepped on you.
Go ahead.
I was just going to ask Zach. You mentioned 65% of the mites on the adult drones throughout the season. Is that same number apply to the mites under the cappings too? So 65% of the mites will be underneath the cappings of drone comb?
I think I need to back up on that 65% number. That's how many were bit, not that 65% had mites.
That's 65% parasitized.
Yeah.
Right? Not necessarily having a mite at that moment.
Okay.
Yeah. So imagine imagine I'm the mite and I first feed on Matt and then I go over and feed on you, Ian. I'm still just one mite out of 6 of us. So what's that, like 18% or 17%? But if I feed on 2 of you, this is going to be really bad math on the fly. What's that, 33% bit?
Yep.
That's how we got that 65% is even though like the alcohol wash there was 4% and those mites at any given time, actually I think it's in the supplemental, had far less. When over 9 days, if you just count up every individual that once had a mite on it, it turned out to be 65%.
Oh, I got you now. So the damage is being to the drones. Yeah.
Yep.
It skewed to the drones, the damage, not so much
early in the season. Yep.
Yeah, okay. So So that's why I asked you that question earlier on. If I just pick off drones, if it's going to see like such a significant difference, and it's not.
That's why you were asking it that way, and I was trying to in the real time Yep. Okay. And so to be clear too, then the takeaway later in the year when we say almost 60% of workers are parasitized, it's not that in that colony, if I scooped up bees, there'd be 60% of those bees with mites on at that time. The mite literally bit one bee on Monday, left for another bee on Tuesday and another on Wednesday. At the end of the week, when we count up all of the bees that at any point had a mite parasitize them, it turned out to be 60% of the colony. And that's, Ian, where honestly, if you guys can put your heads together of how to work your operations systematically to prevent that, I mean, you'll be sitting on gold.
Yeah, like target treatments right now. We gotta kill whatever's in there now, the best we can. It's I don't want to sound like I'm complaining, but I'm trying to use formic to knock some mites down here before the flow, and trying to use thymol, but maybe the formic's not working so good today because it's a little bit cooler than it was 2 days ago. It's just the variability of these treatments we have. It's tough. Be nice to be able to have a treatment like another Apivar chemical treatment where you put the strip in and it's not, its efficacy isn't as reflective to the conditions that are around it. But that's just not in the cards anymore, I don't think.
So Zach, what can you say about drone trapping in terms of like old school calling drone brood, drone frames, stuff like that? How does that play into all this?
If someone's a hobbyist or a sideline beekeeper, I think there's two things they can do to improve their colony survivorship. That's the most lowest hanging fruit. One is just move the colonies further apart. I think that was shown both by Seeley and Delaplane as just easy strategies, right? And obviously, if you're a hobbyist or backyard beekeeper, that's very easy. Much more difficult for everyone that's parasitized. And the next is drone comb removal. Drone comb removal is beautiful. You're actively moving a vector as it reproduces. So you're essentially trapping it, removing it. You're preventing all of those bites on your bees. It's phenomenal. The problem is you have to do it intensively. You can't go out, scrape a few drones in between your combs and call that drone comb removal. You're still also very susceptible to any crashes within your operation or across operations. And if you're in a high density area, I always quote like Florida down here, right? There's just so much movement of bees between yards from crashes that you're very susceptible to intaking more mites. So I love drone comb removal, but it's not a silver bullet.
Okay.
Very labor intensive. Randy Oliver wrote a very good article on that, and some nuances as well as far as slowing them down, laying the drones, that sort of thing. So a person would have to look at the article to get all the nuances that he kind of came across in doing that. I have done that, and I got to say it either didn't work at all or it worked great, because I would pick out the drones and I wasn't seeing any mites. So maybe it was working too good. I don't know.
Zach, given your kind of your familiarity with mites so intimately, could you just kind of, this is a question I get a lot from beekeepers, is like, what is the exact interval of mites transferring onto bees and back into cells?
Mm-hmm.
So I guess that question could apply specifically to the foundress mite or to the daughter mites. But can you talk just a little bit about what we do know about that? In terms of
actually,
for oxalic, interval treatments and stuff like that. I think people, that's where they come at it, right?
Yeah, I don't understand that conversation though, just because your brood is continuously emerging. So trying to time interval treatments based upon continuous emergence of mites, and then some of them will happen to be going back into brood at a different interval than others doesn't quite make sense to me. But we can talk about their biology and some gaps in it. I'm going to forget the name of the lead author on the paper, but in the 90s, they showed that there's essentially two cohorts of mites. There's some that stay on what was called the phoretic stage for a very short period of time, and then some that stay on for a long period of time. The type of mite or a difference between those mites wasn't defined. So one was on average 4.5 days. The other one was either 10.5 or 11 days. You partially brought it up, Matt, and my hypothesis is that your callow daughters, the ones that haven't reproduced yet, is engaging in one behavior, and your foundress mites, the older ones that have already reproduced, are engaging in another behavior. And we often refer to mites as this one homogeneous group, when the reality is there's lots of different ages, and they've reproduced so far, or they haven't reproduced. So I think they're actually engaging in different behaviors just based on being callow or foundrous, is the hypothesis there.
So
Yeah.
to back up to the timing on that, let's take a crazy situation. Oxalic acid vapor is actually very effective, and let's say that it's going to kill 100% of the exposed mites. So then you're right. You always have that progression of mites appearing out of the brood, et cetera, and even influx from in the front door, obviously. So the assumption then is that if the percentage, and let's say in this crazy scenario that you're going to kill 100% of them, that interval, say 5 days, just to throw a number out there, then you're going to get all of the additional mites that are exposed before they go and hide in a cell again. Does that make any sense at all? And I know you're not going to kill 100% of them, but it's really effective. So you're going to kill a lot of them.
You're going to kill a lot of them, and I think we should fall back on a couple facts. We're never going to get rid of mites. They're endemic.
Right.
They're an incredible parasite that loves our host. Our goal is to effectively manage them. And at least speaking from here, we haven't quite figured that out in the States, right? We're going through this tumultuous period where it's very expensive for beekeepers to manage mites. And when we get behind on it, there's consequences for those operations and anyone that gets an immigration of mites, especially like late summer up in that upper Midwest area, we just get the concentration. So a better real question is, how can we keep those mites at levels where they're not impacting the health of the colony? And I think if you describe there, if you could do one treatment and have such low levels of mites that they're not impacting your bees, then fantastic. Then you just mentioned the major parameters that you have to watch out for. Their reproduction and them coming through the front door. And I think I can't speak as a Manitoba beekeeper of how you manage those two parameters, their reproduction and out through the front door.
With the usage of oxalic acid vapor, I've always felt that part is missing, because it's not an effective tool. If you go to get some Apivar strips, like Ian was saying, in the spring, and you put those on the 1st of April, they're going to be in there for 6 weeks. You've got a long-term control there, and you're killing round after round of mites, and you're getting excellent control over time. Oxalic acid vapor, you get excellent control for 24 hours, right? And so I think the missing component with oxalic acid vapor has always been, when are you applying that treatment, and how often are you applying that treatment? Because it's not a one-time thing. It's a every so many days thing, in my opinion, to be effective.
I'm assuming that's not sustainable based upon your labor that you have.
Well, it is a lot of work, but
yeah,
with the tools we're getting today, it is a little more in reach.
Well, let me pose a question there. What if you wanted that early spring, when you have a lot of inclement weather, with either an Varroa or an Apivar, you pull that Apivar, what would be, would it be something you're interested in, where you're running either the oxalic release strips that does that slow amount through the whole time that it's in the colony for that next stage, or a Varroa product, one of those where you're going to have a low active ingredient for a long period of time? And that would run you out. So if you put yours in April, you're pulling that in the beginning of May, then you put your next one, that's running you right out through June, right? What about that long period of time where you have essentially slow release products in your colonies that are preventing those mites from building up and providing that protection?
Well, fortunately there are more options than just one. And my question was just, specifically about oxalic acid vapor, but that there seems to always be missing information there on how we should be using it, because it's not a one and done. It's not It's not an Apivar treatment. It's not even a Formic Pro treatment. It's one treatment is part of a system, I believe.
Mhm.
Not, it's very, very effective against a certain cohort of those mites. Very effective against that certain cohort of mites. However, you're always getting that new population coming out of the brood, etc. So that one treatment, that's not. It's one round is not the treatment. The treatment is a succession of usages of it, and that's what I'm always just wondering about is what's the best way to use that product, because like Phil said, we're seeing problems with oxalic strips left in too late, like Naz was saying, and as Phil has found out, thank you, Phil, for doing that research. Over winter, that's a no-no. We want to avoid that. We know we can, quote, overdo it in certain ways. Oxalic acid vapor seems to be pretty well tolerated by the colonies. But it has that reoccurrence that we need to. I don't know if it's just a matter of a higher and higher dose. I don't really think so.
No, I don't think you're going to solve that.
It's the recurring dose kind of thing.
Yeah, because it's not a matter of just adding more vapor. It's still going to be out of the colony several days later, and then you're more vulnerable, as you put.
Yeah.
And I should point out, just in case it doesn't get covered here, don't use vapor inside of your sheds. That's not a good idea. Okay, great.
Yeah. See, Phil's taking it for the team here regularly, so we're so thankful for that.
Yeah.
Yeah, and Brad, I mean, it's a really good point. And just to add a bit onto that, I know that we saw in the US, I believe your label for oxalic has been changed in the past year or so to increase the dosage. In Canada, the label has not been increased to that extent. However, we do hear pretty commonly from beekeepers that they're running about 3 to 4 grams per treatment, and they're doing about 5-day intervals. And that seems to be the middle ground of what most beekeepers are doing, and that is not on the label. I can just say that. So I think Brad is really pointing that out, that there's a lot of there's a bit of unknowns maybe in the research, but especially on our label here in Canada, that's not an approved method. So for sure that's there. Zach, if I could ask you, because I think we're all thinking about this, how do we get our hands on drones? Somebody put in the chat, and I think a lot of people will have this question. What if we put in a queen excluder on hive entrances when we get to a bee yard in the beginning of spring and summer and wash 100-ish drones? Like, is that something that's going to help you if people go and try that? They need to get the young drones. Can you just explain about that?
Yeah, so my research states that the bee most likely to have a mite on it is a 2 or 3 day old drone. And those are the ones that are most likely still to be in the center of your brood nest. So that's why we sample them. But they're bringing up a really interesting point. And I want to put it out. When I did this work, it was my PhD. My PhD took 4 years. 3 of that was this pretty intense sampling, and then the viral transmission work, right? So as much as it was a lot of work, it's a pretty narrow focus at the end of the day. And there was, I'm horrible with names, there was a Canadian researcher in their thesis that showed that the bee most likely to drift between colonies and get accepted is a drone. Right?
Yep.
So what they're bringing up as in terms of a sampling method, probably not great, because what are you going to tell from it? And you don't necessarily know if it's the drone from that colony. But an incredible master's project or possibly PhD is asking, how much natural immigration do you get just from mites on drones moving from colony to colony in your operation? And is that occurring? We tried it. It's extremely tedious work to hand paint drones and hand paint mites and try to recapture things. But I think that's necessarily a fun thing to think about. Your drones have very little fidelity, and your bees are very likely to accept them. And we've had 2 and 3 day old drones where we found them in colonies because we hand paint them across the yard, right? So they do move quite a bit. So I think they brought that up. I don't think it's a great sampling method. You're not going to accomplish maybe much from that. But if we were to think about looking at drones in front of your colony and entering it, there's a really fun thing to think about where there's definitely a gap in knowledge.
I have a question for you, if I may. Is there a way, like as you as a researcher, is there a way somehow to make something to attract the mites? This question been asked already once to some California researchers, and they said, "Well, we don't have a broodless period." Well, we do.
Yeah. So, the North Dakota state beekeepers and the California state beekeepers gave me 2 small grants to do that, because we showed essentially this big gap in knowledge where that work had been attempted before, but the whole focus was on brood. And we show pretty clearly that they're actually very selective on certain bees, like 2-day-old drones and 2-day-old workers. They're also interested in another 2-day-old bee. And we took a left-hand turn in that research. Ticks, they form aggregation feeding. They have aggregation feeding pheromones, which means when a tick starts to feed on something, they'll release a smell, a pheromone that calls other ticks to it. So we spent a whole summer looking at if mites are releasing a feeding pheromone, because then essentially we would just capture it. We were working with the GCMS lab. We would just capture it, synthesize it, and then try to make a bait trap. But to answer your question, we still have funds left over. We actually found a pretty big gap in knowledge in who they're feeding on, and now we're pursuing essentially the bees that they're very attracted to. We're hoping to capture that essentially perfume or bouquet, if you would, and see if we can make a sticky trap that you would just throw into your colony before you go into sheds or when you just come out of sheds. Actually, the idea is you come out of sheds, your colonies have very little brood, and you throw it in. So that's.
So you think it's
I love the question. What's that?
You're thinking it's maybe possible, maybe.
I mean, your apple growers and stuff. I mean, they already have traps like this. They have those pheromone fly traps. So there's uses, and we also have moth traps like that. They're just pheromone bait traps. So it's just a different version of a pheromone bait trap.
Yeah.
Even if we can
would
get
do so many things. Sorry to interrupt. That would do so many things for you, because it would not only, mite treatment, who kind of trap the mites or get rid of the mites, but it would also tell you information about the infestation level, right? Just like a sticky board would. So that's I love that idea. Sounds like a job for Kara Wagner.
I hope it's a job for Zac Lamas. We still have funding for it, but just to throw my name in. But no, Kara's phenomenal. That is the thing, and there might be that it might. My hypothesis is it wouldn't work all the time, because there's a lot of competition in the middle of the summer for everything that they could feed up on. But there might be select periods of time, i.e., like when you're in sheds or coming out of sheds, where it'd be a perfect treatment, and obviously one that you can use in any type of weather.
Nice.
Yeah.
There's also no drones on those hives in the shed, so anything that smelled remotely like any kind of drone would probably be pretty attractive to them.
That's true.
The difficulty is they all chemosensing isn't their only way of sensing around a colony, and so hopefully it's not the only driver. But
well, folks, last round of questions for Zac. He's been very gracious and going through all. I know we're a little bit all over the place, but absolutely excellent presentation. I really appreciate it. But I'll leave it out to the guys here for some final questions, and not too much more we have coming in the chat. So yeah.
Yeah, I just want to say thanks, Zac. I love the conversation. Lots to think about, lots of chatter on the chat page too. So I appreciate your time.
Yeah, thank you so much. This is, I process things a lot slower than most people, and this is going to give me a lot to think about, and just a new paradigm about these drones. Alcohol washes in the fall drive me bonkers. Do a wash, do a treatment, do another wash, and you have more mites. But then it's like your wash is like your treatment is breeding more mites or something. It's so frustrating, and the information you're getting is just. I mean, what does this information even mean at that point? So that's that's really good information to know.
Yeah, just that whole shift that happens, the shift within the late season, where they move on to the workers and do the damage to the workers at that time. That's quite interesting. I'm not sure what to do with that, but it just helps understand the dynamics going on within the nest at that time.
Mm-hmm. Well, I'll pose this back to you all. Which one? I've seen most of you online. Ian, I also love the way you winter singles. Seriously, it's just amazing. I'm glad you post that stuff.
Yeah, well, it's
and
Phil over here. Phil is I mimic everything Phil does.
Right
and I mimic what Ian does. So.
That's a nice network that you all have then. But
yeah,
no,
Phil's my mentor right from the start. Yeah, he's my guy. Whether he knows it or not.
Well, this is fun for me, but I think you guys keep saying something that I should point out, which is you are sampling mites. You are trying to sample for mites right now, and your colonies keep telling you the same thing, which is mites are at such a low level, they're not impacting the colony health right now. And I think there's some questions like we need to stop asking them, because the moment we stop asking them, we ask different questions. And once I ask a different question, my brain engages in a different way. So I think asking the question is, what can I put in the colony now, or what management do I engage in now, so that we keep them at a level where they never rise? That's very different than when do I have to treat in the fall, right? If I ask when do I have to treat in the fall, then I start looking at a calendar. If I ask how do I keep these mites at a level where they're not impacting worker bee health, now my brain really has to turn on. And this is I have this talk online, I'll post it in the comments. It's a longer version of this, it's about an hour. I never tell a beekeeper what to do in that talk, because you all have supercomputer brains where you've been in thousands of colonies over years, right? All you need is a lot of new information, and your gears start turning very quickly, and people have adapted this in different ways. So first off, thank you very much, and I'm psyched to have these conversations.
Thank you. Yeah, I kind of like, we teach a intro to queen rearing course here, and it's kind of an analogy for me that works for me is like how to absorb this, or why it's important to understand and absorb this new information that you're giving us. It's kind of like you can be taught to raise queens and kind of go out and do the grafting and put it in the strong colony and do all the right stuff. But when if you don't understand a little bit of what the bees are actually doing and how many feedings they're giving that larvae and what you're setting up there, you're kind of doing it a bit blindly. So I think your talk here, Zac, is also illuminated, like Ian just pointed out, like what's actually going on in the colony. We're not seeing, but there's that shift, right? From the drones to the workers. So for me, it's just, it just seems absolutely critical to be well aware of this. And like you said, lots of questions about now how to kind of move forward, but starting with the long-term protective treatments and such like that. So thank you very much. Yeah, and I'll end the stream unless there's any last words anybody wants to get in.
Oh, thank you, Zac.
And I will just note that we're going to have another webinar coming up in July. It's going to be focused on RNAi. We'll get some results out of some field trials in the US, New Zealand, and here in Canada. So I hope you guys can join us for that. Have a good night.
Night.